Hello everyone, welcome to a new video. My name is Roy, aka Bloody Bananas. And in this video, we're going to talk about what are the most important data science skills in the industry and where to learn them. I'm going to show you the very basic way to learn them, free of course, and then I'm going to show you what worked the best for me, and I consider that as the fast track way to learn data science skills overall, holistically, in a very fast way, and in a very good way as well. So without further ado, let's get started. First of all, I'm just going to briefly talk about what makes up data science. You've probably heard this from my last video on what skills to put up on the data science resume. And these three sections are basically what I consider to be the most important part of data science. There's math and statistics, where it makes up the fundamental knowledge. And then programming helps you implement and really apply those theories into practice. And then, of course, you have the business application to really show the value, to really bring value on the table with your data science skills. And let's start with them one by one. So we'll start with math and statistics. So these are the things that I consider to be very important from math and statistics that are very often used in the industry. So first of all, linear algebra, calculus, probability theory, these are the most fundamental things that you need to understand in math and statistics about data science. Essentially, data science is really just made up of these three parts, and everything is derived from these three sections. And then you have statistics, A/B testing. You have to run some experiment setup to test a new change in the business, maybe a new product or maybe a new treatment, and you want to measure how effective it is. You have to set up the experiment. There are a lot of assumptions that you have to go through, and this is where all the statistics comes in, right? And then next up, the distributions. You encounter a very wide range of distributions, normal distribution, binomial, and there are a lot of assumptions that you have to make for each distributions, and there are a lot of things that you can learn just by looking into the distributions of the data. And then next up, usually people consider this to be the fun part, which is the machine learning theories. And these are called machine learning because even though you understand the theories on how to calculate these things, it takes very long time if you try to calculate them by yourself. And that's why we rely on the machine to compute them for us. And then we can use them to make predictions on future events. And then next, we're going to need the performance metrics. All of these performance metrics are essentially made up using mathematics as well. And it's important to understand why these work and what time to use what metric. And my suggestion on how to learn these, obviously, if you're in school, you can take courses. If you're a math or STEM major, you can take a lot of math courses to learn these. But if you don't, that's totally fine as well, because there are tons of free courses on Coursera and Udemy. And you can really get the very basic fundamental knowledge down through these resources, Coursera and Udemy, those online learning courses. And the one that I really recommend is the course from Andrew New. He has his entire machine learning course uploaded on YouTube for completely free. And you can look him up by just looking up his name, and you can find all his courses for completely free. And they're very, very helpful. Imagine going to one of the most prestigious schools for free, right? And learning one of the most popular course for completely free on the internet. And that's essentially what Andrew New did for all of us. You can learn a lot of the machine learning theories. You can learn a lot of the mathematics just from watching his videos. And also keep in mind how in depth you really want to get into the math and statistics in data science. Because if you're more research focused, then I would say this is probably the most important part of your job, is essentially using the theories to develop your own theories, essentially. And it's everything that you do is built on top of the math and the statistics knowledge that you have. But if you want to get a more business oriented job, then perhaps you need to be more focused on the business section, and you don't really need to worry about the math and statistics as much as the more research focused jobs. So it really depends on what you're looking for to determine what level of proficiency that you need from this section. And then next part, we're going to talk about programming skills and why these are important and how they're being used in data science. So you need data manipulation because a lot of times the data doesn't look the way you want. And this is where you have to manipulate the data, do a lot of data one juggling so that it looks the way that you want, right? So you can really do more analysis. And data visualization is probably the easiest way to bring value directly from the data. To show your stakeholders what you're doing and what you could do in the future as well, and just deriving very simple analysis. And then next up, feature engineering, because a lot of features are not useful by themselves, but you can do a lot of things to make sure to create new features that are based on the old features, and these new features will turn out to be more important and more significant for your analysis. And the next part, the machine learning model development. Of course, these are machine learning, so you have to teach them. You have to tell the machine where to really learn, right? So yeah. And then I would say the next two section is probably more important once you really get into industry. You can probably learn them during industry as well, because every company is different in this part. You need to do a lot of simulation and testing before you really deploy those changes. And for deployment, you have to go through them for every experiment change, or for all the modeling changes, or when you're creating a new model. So these are all the things that you need to learn once you get a job in the industry. And the languages that are generally considered to be the most frequently used are Python, R, and SQL. There are also obviously Java, C++, really depending on the industry that you're in. And here on the right side, I'm listing some ways that you can learn these skills. So if you're in school, again, if you're in STEM field, then the easiest way is probably just to take a computer science course. And I'm sure your school offers CS 101, whichever school that you go to, right? And then if you can't, if you're not in college, you can look up those college textbooks for completely free online. If you look up Python textbooks or programming textbooks, you can find hundreds of them for free on the internet just from Google. But if you don't want to learn from reading textbooks, that's totally fine as well. I mentioned these names before: Udemy, Udacity, Coursera, W3 School. You can really learn the basics of programming from these courses, and they offer a lot of those courses for free once again, where you can just get the fundamentals down to learn what different data structure looks like, how to write a for loop, for example. Just very basic programming skills. And if you get those fundamental skills down and you want to get more specific things done, for example, how to reverse a string, then you can look that up on Google or Stack Overflow, and you'll get thousands of people posting their own code on how to do certain things. And what you can do is just copy and paste them. And essentially that's what 90% of the time a programmer was spent on their job anyways. And next up, we have LeetCode, Strata Scratch, HackerRank, and these are important for preparing your interviews, because LeetCode, HackerRank prepare you for those algorithm interviews that you might have or might not have, depending on the job, yet again, to just do some algorithms. And then Strata Scratch helps you with the SQL preparation, and we're going to talk more specifically on those for my future videos on how to prepare for a data science interview. And next up, personal projects. For me, this is the most important thing on how to learn data science skills. With that being said, let's go into the fast track way, and it really involves doing projects. And I'm going to show you how that's being done. The fast track hack, pun intended, because it's programming, right? Get it? All right. So the keyword that we're looking for is Kaggle. All you have to do is follow what I'm doing here. Literally, look up Kaggle on Google and open it up. Look into the competitions. You'll see a lot of those competitions where they provide the data sets. And there's a really wide variety of those applications in real life. So, for example, this is a very famous one where you try to forecast housing prices. And it shows you the description of the data, evaluation metrics that they like to use, and what the tutorials are even. And you can look into the data sets that they're offering for completely free. And this is the best part. You can look into other people's code. And what they're doing with their notebooks, how they're preparing the data set, what they're doing with the data sets, what are some basic analysis they're running, and what code they're using, what outputs they're showing. And essentially, this is all the knowledge that's in front of you, and what you can do is copy it. And then you can add your own flavor to this code, and you can test the outputs. And you're essentially making other people's knowledge your own in a way. And this is my favorite part about doing these Kaggle competitions, is that you're really learning a lot of things from other people, from the best data scientists, and you're making them your own. And if you want to try new data sets that are not limited to the competitions, you can look them up during the data sets section. For example, if you're interested in chess, you can look up these chess positions. Maybe you want to build a stockfish engine yourself. You can look them up. Or if you're interested in finance, you can look into some finance indicators on how to predict stock prices, right? If you're into animals, on how to differentiate between the animals, you can look them up as well. There's so many different data sets, and they all have other people's code. You can look into what the data looks like. You can go into the other people's code, what they have done with their analysis, and again, copy and add it. And then you can try your own flavor, and you can make it your own, right? And essentially, that's my fast track way of going through these exercises or just personal projects. And then you're really learning a lot of things just by working directly on the projects. And with that being said, the Kaggle competitions also help with this very important part of data science, which is domain expertise. Personally, I think most of them comes from industry experience. But if you're still in school and you don't have industry experience, then you just have to simulate them, right? And a lot of them comes from your own personal projects. Yet again, you want to look into what are the important business value that you can drive from the data sets and how you can achieve that. And what some of the evaluation metrics you need to keep in mind of depending on the domains that you are working with. For example, we're looking into banking, then there's most likely more fraud and risk analysis. So you might want to look into how much money you can save for your company. Whereas for finance quant, where you're looking into strategies, also risk, but in trading, right? Trading equities. And you want to look into how much money you're making. What's the for example, Sharpe ratio is a good metric, right? And that's something that you wouldn't use for any other industry, but it's very important for finance and quant. And then next up, there's retail, where you look into the supply chain analysis. There's healthcare, where you this is very there's a wide range of this. Sometimes you do some trial analysis, survival percentage, mortality rate. Personally, I've never worked in healthcare, but that's what I've heard. Or you could look into the brain picture and see if someone has a disease or not. And then social network, this is also probably one of the most common one, where you try to develop, for example, a recommendation algorithm so that people are more engaged with your platform. You can really make those 15-year-old, 12-year-old people just completely addicted to the internet and watch videos that you recommend for 10 hours straight. Yeah, that's something that we do, right, as data scientists. or you just provide the best ad experience to people that well, the algorithm thinks. And then we get to the research part. And this part is really dependent on what type of research you do. For example, if you're just developing some algorithms in data science, then you're probably looking to how they can help make the predictions more accurate, or making the algorithms more easy to learn or faster to learn, right? And then scientific, again, this is a broad area. Maybe some NASA uses data science as well to make predictions on their rockets. I'm not entirely sure because I'm not familiar on that section. But again, the most important thing is to really find what industry you're interested in. And if you're not in school, or if you're in school, then try to simulate those experiences, even if you don't have them. For example, if you're into retail, then look up some data from Walmart, Kroger, and how they're dealing with the supply chain, right? And how you can bring value to their businesses. And you want to keep thinking about that, because essentially data science is applying those skills that we have to bring business value. Otherwise, why use data science? And with that being said, that's the end of the video. Thank you guys so much for watching. Again, all of these resources are free. You can, I think anyone can do data science as long as they follow the right track to learn the skill sets. It's one of those things where once you get in, you realize it's not as complicated as you might have thought from the beginning. And personally, I know a lot of people that didn't even have any math background and transitioned into data science or programming. So it's certainly possible if for you. I don't know who you are, but I believe that it's possible for you as well. And once again, if you guys like the video, make sure you hit the like button and subscribe for more. And I'll see you guys in my next video.